Okay, hi guys. I'm going to be doing the lab number 2, electromagnetic introductory. Okay, so first of all, I'm going to show you all of the supplies you're going to be needed, which is the device itself, which is there, the large magnet, the small magnet, and I'm going to even show you this cool flashlight. Okay, cool. So we're going to go to number 1. In task 1, you're going to take the large bar magnet and move the north end into each of the 3 wire coils, and then try to do this. Try to do this with the same speed each time while observing the needle or the anemometer, which measures the amount and direction. So task 1, what is the same? So first of all, you take the large magnet and you move it into Okay, so you're going to be moving the north end, which is the red end, into each of the 3 wire coils. You're going to watch to see if and you do it at the same speed. Okay, and I'll give you a minute to document your answers. And number 1 says, what is the same? On number 2, it says, what is different? So when you're moving the large magnet into the large, medium, and small one, you're going to document what is the same and then what is different. And on number 3, it says, task 1, finish the sentence. When the number of coils increases, the current blank. And then you should be able to see what happens with the large magnet. And I'll give you a minute to document your answer. Okay, now on task 2, using the large bar magnet and the large coil. So I'm going to be using the large coil, and the large magnet, right? Move the north end into the wire coil and repeat using the south end of the magnet. Try to do this with the same speed each time, and while observing the needle on the anemometer, measure current amounts and direction. And you're going to notice the needle move. So you're going to document what time, what is the speed of each time, and what the needle does, in which current direction. Okay, I'll give you a minute. Okay, and then using the south end of the large magnet, the south end is the blue part, you're going to do the same thing. Go into the large coil, do this several times at the same speed. And what is happening? So in task 2, it says, what is different in the current when you're using the north and the south magnet? So what is happening when it enters and then when it leaves the coil? Okay, number 7 says, finish the sentence. When a south magnet pole is used, the current flows. Which way does it flow? And then when the magnet enters, and then the current flow blank when the magnet leaves. So filling in the sentence, when the south magnetic, which is the blue part, is used, the current flows which way, and then when the magnet enters, and then the current flows blank when the magnet leaves. Okay. Number 8 says finish the sentence. When a north magnet pole is used, the current flows blank, and when the magnet enters, and then the current flows blank when the magnet leaves. Okay, so you're finishing that sentence. When the north magnet, which is the red part, pole is used, the current flow blank when the magnet enters, and when the current flows blank when the magnet leaves. Task 3. Using the large bar magnet and the large coil, move the north end, which is the red part, into the wire coil, and repeat using the north end of the small bar magnet. So here's the small one. Try to do this with the same speed each time and while observing the needle, okay, which is going to measure the amount and the direction. Assume that large magnet means a stronger magnetic field. And I'll give you a few minutes. Okay, task 3 says using the large bar magnet, right, and the large coil, move the north end into the wire coil and repeat using the north end of the small bar magnet. Do this with the same speed again while observing the needle. Okay? Oh, I'm sorry, I just did that one. Number 9 says, task 3, finish the sentence. The current produced by a moving magnet is blank to the strength of the magnet. So you want to look at your answers. Directly related, inversely related, which means opposite, or not related. Okay, finish the sentence. The current produced by a moving magnet is blank to the strength of the magnet. Okay, and for number 10, do not Google your answers, but it says the lab was all about characteristics of electromagnetic induction. And so in your own words, what is electromagnetic induction? Okay, what is it? And I believe we're at the end, but I just kind of wanted to show you the flashlight too, which has a magnet inside and it's clear, just so that you see if you shake it, what happens. And you turn on and off the button, just for a fun thing. Okay, thanks guys.